Hello everyone. Let's study the first chapter of physics, units and dimensions. Before going into units and dimensions, it is very important that you understand what is physics and why do we study it. So to understand what is physics, let's take an example of a game called football, right? So suppose you go to a stadium to watch a match of football. Now here the thing is, you don't know the rules of football. You have never seen anyone play that game. You have not heard about it before. You have not been told how it is played. You have not been taught. You know absolutely nothing about the football. But you tell me that you are confident that once you go and watch the game, by observing the game, you will be able to figure out the rules of football. So you go, you sit in the stadium, and even before the match starts, you started writing down your observations in your notebook. So first thing you observe is it's an outdoor game. Then you observe it's a team game, right? You also observe it's played with a ball. Now there might be a hint here that the ball and foot, something to do with the foot and the ball, so you might be supposed to kick the ball, and you are absolutely right. You observe further that the kicking of the ball is allowed, but handling of the ball is not allowed. After a few minutes, it seems that one player hits the other player and does a foul and is handed a yellow card. So it seems that yellow card seems to be like a warning if you do a severe foul. And you think, yeah, that seems to be all the laws of the football. You just kick around the ball and you don't hit the other player. That's all there is to it. But suddenly the one team puts let's say the team A puts the ball in the net of team B, and whole of the stadium, at least half of the stadium, is shouting goal, right? And the score is changed from 0-0 to 1-0. So that means goal seems to be the objective of this whole exercise. So you note it down. Yeah, when it's netted, it's called a goal, and then that changes the score of whoever teams puts the ball in the opposite net. Meanwhile, the goalie handles the ball and he is not penalized for it. So it seems there is a exception to this rule of handling. So you go and edit this rule here. So you write that there is an exception where the goalie can handle the ball, right? Then the player who already had got yellow card before, he secures himself another yellow card, and those two yellow cards in turn become a red card, and this player is shown out of the game, and he is not replaced by anyone. So now this team who did the fouls will play with one player less, so they are at disadvantage now. And so on, you watch it some more, and it seems that it's a finite game, so it goes on for some time before it finally stops. Then at the end of the game, the tally of the goals is done, and if the goals of team A are more than goals of team B, then team A is the winner, and if goals of B are more than goals of A, then team B is the winner. So at the end of the game which you watched, you have certain understanding of how this game is being played. So you observed the game for some time and you got some idea about how it is played. However, when you attend the next game, you learn a little bit more about the same game. So it's not comprehensive, you still learn something more, you go to the next game. For instance, next time when you go, you understood that there is one more exception when the ball is thrown out. I mean, when the ball is out of the boundary, then it's thrown back in. So there is one more exception of this game. So you keep learning about the rules of the football by observing it, and this goes on until you are quite confident that you will be able to predict what happens when anything happens in the game of football. For example, you are confident that if a player is shown 2 yellow cards, then he will be taken out of the game, and the team whoever scores higher number of goals is the winner at the end of the 90 minutes. So you are confident about some rules. So you come back to me and you say, sir, it seems that's all there is to it for me to learn, but how this whole exercise is related to physics? And I would say everything which you have learned while watching the game of football, the same principles apply in learning of the physics. Here the game is played by the nature, and instead of the rules of football, what you observe here are the rules of nature. What I mean by this is, you just look around you. So you will see that there are some things are happening around you, right? There is a light, there is wind. If you clap, for example, there's a sound will come. If you rub two metal objects, the heat is generated, right? If you drop an object, it falls down. And this is the observations which you can do, but at the higher level, the people have observed that let's say the sun and the earth, if they are separated by the distance of r and their masses are m1 and m2, so the people have observed that the gravitational force between them is proportional to the multiplication of the masses, or you can just write it proportional to the masses individually, and inversely proportional to square of distance between them. So this study of the rules of nature is physics. As the time goes, you realize that just like there were exceptions here, there are exceptions here as well. It seems that the object does not always drop. If it is a balloon, if it's a lightweight balloon, it might go up. So you write here that no, it falls down if it is heavier than its surroundings, So you keep editing the already formulated laws, and you keep observing the nature more and more, and you keep adding to the laws, right? So at the end you have a very book, and this book will be your textbooks of physics. Now the question arises that fine, we are observing this, but how anyone can observe this? So how we differentiate between the great physicists and a normal observer? Well, the answer is mathematics. Mathematics is what we use to formulate these laws. What I mean by this is, for example, in the football match, instead of you, suppose a scientist attends the same match, so his diary will look a little bit different. So instead of team game, he might write 2 into 11 players, instead of writing this line, he might write 2y is equal to 1 hour. Instead of writing some time, he may say 90 minutes. Instead of these lines, he may say if GA is more than GB, then TA wins, and if GB is more than GA, then TB wins. Here, while studying the rules of the nature, the same scientists may write about this as it's a conservation of energy. So he may write delta KE, or this is the loss due to the friction. So the difference in the kinetic energy of these two blocks is equal to gain in the heat. For this, he might write that instead of it's always going down, he will write that force is equal to ma. So wherever the eventual force is there, the acceleration will be in the direction of the force. For these so many lines, he will simply write that force is proportional to m1 m2 by r square. So scientists will use mathematics to write the laws of nature in a simplistic manner. So this is not just about writing. So this is one advantage, and when you use the mathematics, you can write the laws in simplistic manner. So write the laws. You see here it conveys the same meaning, but the language is different. So mathematics is a language, that's all. So you can say that mathematics is a language of physics. So with this language we write the laws in simplistic manner. Since it's the language of physics, it cuts across the boundaries of normal conventional languages. So even though this line might not be understood by the people who are not the speakers of English, still this will be understood by those people. So again, it's easy to communicate. Along with these two, one another advantage that mathematics provides is it gives you the tools to simplify your calculations. For example, we have a mountain and we want to find the height of the mountain. So instead of climbing the mountain with simple trigonometry, if we know this angle alpha and beta and we know the distance between these two points, we can calculate the height of this mountain. We don't need to climb the mountain per se. Similarly, Newton invented calculus. He invented calculus to further his studies in science, in physics. They say that need is the mother of invention, right? So this is the same kind of thing. He felt the need of inventing of some tool so he could do the sums faster, and he invented calculus. So to further his studies of physics, he invented calculus. So now you might have some idea about how important maths is, what's the relation between the maths and the physics. It's just that maths is used to convey, to formulate those rules which you observe in the nature. And these rules of the nature, the study of these rules of the nature itself is physics. Now let's talk about the next chapter, units. So let's say we want some water, and the volume of the water we need is around 4 cups. So we write V is equal to 4 cups. So the volume we need is the volume of 4 cups. We can also write this as this is 4 times volume of 1 cup, right? This is the volume we want to measure. So whenever we want to measure something, we call that thing as the physical quantity. So this is a physical quantity which we want to measure. So when we want to measure the volume, we can measure it in terms of cups. Now let's say the length. We can say length is equal to 6 meter. So this we can write is 6 times 1 meter. Suppose weight is another physical quantity, it's a 2 kg, so it's equal to 2 times 1 kg. Let's say volume in some different reference, so let's say volume is we want is 18 liter, so this will be 18 times 1 liter. Now time, so time is another physical quantity which can be measured in, let's say, years, so time is 10 years is equal to 10 times 1 year. So you can see a pattern here. What you see is these physical quantities, right, of the this volume, length, weight, volume, time. So we express these physical quantities as multiples of, so these physical quantities we express as multiples of reference quantities. So when my reference quantity is 1 cup, 4 multiples of the reference quantity is the volume I want. So keep this relation between the physical quantity, which can be expressed as multiples of a reference quantity, in mind. So this reference quantity can also be called as unit.